Maybe you can confirm that you can see my screen.
Yeah, we can see PowerPoint.
Okay, perfect. Just a few seconds to presentation mode. Okay, so good morning or good afternoon, everyone. This is the pre-event webinar for the sprint that is coming in a couple of weeks. I'll start with some brief words about OGC for those who are new to the code sprints. So OGC is a standards body, is an organization whose mission is to develop and maintain standards for geospatial information. And there are many advantages on using standards, both from the client side and the server side. If you are a developer, it means that you get more access to data with less customized code. So the code sprints are part of the standards development process. In fact, they are a very important part, along with the standard working group meetings and GitHub activity. They allow us to put specifications into tests, to prototype new ideas, and to have the opportunity to have in the same room the people who develop the standards editors, and also the people who implement the standards, the developers, all of you. So the goals of the code sprint are, of course, to support the development of the standards, but also to foster implementations of the standards. So we want to have as many implementations as possible, as early as possible in the standards development process, because this allows us to test things early and then to make sure that when standards are published, they are already very with a high degree of quality, and that they can tackle all the use cases that they should tackle. We have a third component in the code sprints, which is more to do with outreach and learning. So for those of you who are in the code sprints for the first time, sorry, I can hear some background noise. I would kindly ask you, if you're not speaking, if you could mute yourself. Thank you. So yeah, so this third component is related to outreach and learning. So anyone who is new to the code sprints has the opportunity to attend a mentor stream where we have created a program with the tutorials, hands-on tutorials at an introductory level, which allows you to understand the standards and also implementation of the standards. And in this code sprint in particular, we are going to have a mentor stream that will run across the 3 days of the sprint. So we have a program for the 3 days of the sprint. So if you are new, you can actually attend tutorials during the entire duration of the sprint. So big thanks to our sponsors who made this event possible. And also to our hosts, GeoVation. So for those who don't know it, it's a venue located in the center of London, in the UK. If you are planning to attend in person, here is the address. That you can also find this information on the wiki page of the event. As soon as you arrive, there will be a main desk where you can check in, and then from there you can take the elevator. And the welcome session on Monday will take place in the large room, the quadrant room, which you will see when you enter through the kitchen. Otherwise, you can also ask someone there. So what happens during the code sprint? We have a lot of discussions and interactions. I think this is one of the main purposes of the code sprint, to enable these synchronous interactions, whether they are in person or online. We also have a lot of independent work so that people can work on their prototypes, tests, experimentations, and so on. And as I mentioned before, we have a mentor stream, which is a curated track with hands-on tutorials. So as I mentioned, we have tutorials during the 3 days of the spring. If you are interested, you can come to the onboarding session, which will take place on the first day of the spring, just after the welcome session. And it will take place in the Microsoft Teams meeting. In fact, all the meetings during this code sprint will take place at Microsoft Teams meeting, actually this same meeting, so you can save the details for later. So there are many OGC standards working groups that register for this code sprint. I think some were just added before this call. You can check them out at the wiki page, which lists the standards working groups that are going to participate. And you can expect that these working groups will have some activities that will be developed during the sprint, and you are very welcome to join them. This sprint will also feature 3 special tracks. So one about GIMI, the other one about GeoSciML, and finally another one about glTF and 3D tiles. And we'll hear more about those and also from the standards working groups with our overview and sprint goals. So we are right on time. So without further ado, I think I will give the word to Gobi to tell us a little bit more about the testbed. I'll stop sharing my screen.
Okay, thanks, Joanna. Okay, so I'll just share my screen. Okay, so this a 2-part presentation to give you an overview of the sprint goals for OGC working groups. And I'm just going to, oh, there we are. Okay, so I'm just going to share my screen real quick, and I'll just go through them as well. So let me just that and share my screen. Could you please confirm that you can still hear me?
We can still hear you, and we can see your screen. It's in the GeoSciML.
Okay, there we go.
I'm
video.
Mark Rattenbury. I'm a geologist. I work for Earth Sciences New Zealand. And I'm not speaking to you in person today because it is probably 2 a.m. in the morning. So I've pre-recorded this summary of what the GeoSciML for the OGC Code Sprint is all about. So in another role, I work for CGI. So this is the Commission for the Management and Application of Geoscience Information. And we have a role to foster the interoperability and exchange of geoscience information and throughout the global community, the geoscience community. CGI sits under the International Union of Geological Sciences, which in turn sits under the International Science Council and ultimately into UNESCO. CGI is, we are a group of 30 or so active members. We currently organise ourselves in terms of a council. I'm part of the council. And we have a number of task and working groups which relate to the standards work that we're undertaking. Included in that is the Geoscience Standards Working Group, and we work or have worked with the OGC in terms of building that standard and ultimately publishing it. And there are a number of other working groups that relate a similar way, data models that we're building. And there's also a vocabulary working group, which I'm currently the chair of. This is what it's all about. This is a geological map of Europe, but it's actually a composite map made and served by all of the geological surveys within Europe. And so what they are doing is serving the geological map information. Those are the colors in the background. And on top of that, they're also serving a whole lot of mineral and mining occurrences for various metals and other commodities. So this is an example of federation of data, and this is being achieved through the use of the GeoSciML data model. The GeoSciML data model was published in 2017. This is version 4.1, and this was part of a joint collaboration between CGI and OGC. And this is the web page that relates to GeoSciML. The web page contains a link to the documentation relating to GeoSciML, and it contains some summary information about what the GeoSciML data model is all about. The GeoSciML data model, when you put it on a sheet of paper, is actually pretty intimidating. You've got a large number of entity relationships and feature types and connections between them, and these reflect the geological reality of the type of model that we're trying to encode. And here you can see some of the detail in what we call the basic part of the GeoSciML data model, and some of the fundamental tables that and relationships. And these include a whole lot of fields and attendant vocabularies which service them.
Okay, so what you've just heard are the goals of the GeoSciML part of the Code Sprint. And what I'd like to, just to finish off, I'd like to give you an overview of the goals for the other standards working groups. So as Joanna mentioned earlier on, at OGC, our mission is to make location information more findable, accessible, interoperable, and reusable. And we do this by combining research and standards development work with the research informing the work that takes place in the standards. The OGC Testbed 21 initiative, which is currently running, includes 3 threads. So this is a research initiative within the OGC. It includes three threads, one on data quality for integrity, provenance, and trust, the other one on GIMI, and then finally another one on conformance testing. We have a number of open source software projects that are participating within the testbed and will be participating within the Code Sprint. One of which is on libheap, one of which is libheap, the other one GStreamer, the other one Apache SIS, and finally Team Engine. So there will be a lot of opportunity during the Code Sprint to interact with the maintainers of these initiatives. So which standards are going to be participating? You can see, so which groups are going to be participating. You can see the standards listed here. So we'll have GeoHeaf. There's a new standards working group that has come on, that is coming online, that will be tasked with specifying how geospatial locations or georeferences should be included in a HEAF file. And then there'll be 3D tiles. You'll hear more about that later on. And then GeoSciML, you've just heard from the message from Mark regarding the work that the Code Sprint is going to do with regard to GeoSciML. And then GeoSparkle, so if you're into RDF, so that will be there, or if you're into linked data, that will be relevant. And then we've got a number of OGC API standards that that will feature in the code sprint. So the goals for the sprint with regard to OGC standards will be to develop prototypes or prototype implementations, to test those prototype implementations, to identify opportunities for further innovation, and to provide feedback to the editors, working groups, and testbed participants. That's what we're looking to achieve. That's what we're looking to do during the 3 days of the code sprint. So there'll be ample time to interact with standards editors, but also implementers of those standards. And that's it. That's all I have. Thank you. Back to you, Joanna.
Okay, thank you, Govi, for the presentation. So I think next we can go to the GIMI presentation. Can I just confirm that Joe is on the call?
Yeah, I'm here.
Okay. Hi,
so
Joe.
I'll go ahead and,
Would you like to share your screen, or you prefer me to run the slides?
I'll go ahead and share my screen.
Okay, thank you.
Okay, so are you seeing that now?
Yes, we can see it.
Okay, all right, thank you. I'll go ahead and get started. So my name is Joe Stufflebeam. I'm a member of what's called the GEOINT Media Standards Board, which is a government entity in the U.S. that focuses on imagery standards for use across a very wide variety of applications. And we are currently forward-looking. We're looking at emerging standards, kind of a new architecture, and GIMI is a core part of that. And so I kind of want to describe that in terms of what GIMI is and how we see it being applied across a wide variety of industries and use cases. So first off, GIMI stands for GEOINT Imagery Media for ISR. The current architecture in the U.S. is really developed around both still imagery and motion imagery, and those today are completely different standards. So there's very little interoperability from a software perspective between those two worlds, and GIMI is intended to kind of harmonize that. It's a next generation format. It's documented in what's called NGA standard 0076-01. And so that's the document that outlines all the features and capabilities within GIMI. Fundamentally, GIMI is a profile of ISO-based media file format, which people are familiar with MP4 for videos, and then HEIF for still imagery. And HEIF is actually a profile of ISO-based media file format. These are two of the more common formats in the world, which is one of the primary reasons that we chose this architecture, because we're really targeting high levels of interoperability. And in addition, we want to be able to leverage the wide amount or the broad amount of software capabilities that are out there. And so this effort in OGC has been really important for us in terms of foundational software development and kind of building up the capabilities such that programs who choose to adopt GIMI will have these tools to work with. So the work that's being done in these test beds is really critical for us. And another important aspect of GIMI is it's really kind of paired with what we call the imagery domain ontologies. The architecture that we're developing leverages ontologies such that we can take advantage of semantic information within our metadata. And so that's a kind of a core part of the architecture. And so the testbed is really kind of investigating and looking at this combination of, call it ISO-based media file format and ontology structured metadata, and how these things function together, especially over cloud-based interfaces and those kinds of things. So when we look at our use cases, this was kind of our primary design point for GIMI and IDO. Again, still imagery, we think about things like satellite imagery for geospatial, or it could be still imagery off an aircraft, whatever it happens to be. GIMI provides a container mechanism for that still imagery. And then with respect to motion imagery, the Motion Imagery Standards Board in the US defines motion imagery as class 0, which is raw, uncompressed, Imagery class 1 would be broadcast type formats, HD, 4K, those kinds of things, those standards. Class 2 is really geared more toward scientific type systems, machine vision cameras, where really there's no constraints on resolution, bit depth, frame rate, those kinds of things, number of bands. And that includes things like large volume motion imagery, where you've got gain sensors to create extremely large arrays of imagery. And then finally, what we call class 3 is all the stuff that we refer to as being out in the wild. And that could be your cell phone camera or a drone camera, security cameras, those kinds of things. And those come in all shapes and sizes and formats. By choosing ISO-based media file format, that gives us a good opportunity to at least be able to ingest things that kind of come in from the wild, because in the world we live in today, that's a primary source of imagery for all kinds of use cases. So looking at kind of our emerging geospatial imagery standards, so when we talk GIMI, it's really one part of an ecosystem. And so I just want to give people kind of a feel for what that ecosystem looks like. And so again, if we look at all those use cases on the left, wide variety of systems and capabilities, they produce not just still imagery and motion imagery, but things like multispectral and hyperspectral and synthetic aperture radar, and we're looking at sonar data and those kinds of things. And so we really targeted a generalized capability with GIMI such that we can basically provide containment for all types of imagery and things that maybe wouldn't technically be classified as imagery, but it makes sense to carry those in the same container for workflow reasons and those kinds of things. And so, again, we're looking for very general support. So we start with ISO-based media file format. And again, this is traditionally a motion imagery file format. HEIF has been added to that, so that addresses our still imagery. Then we have to look at codecs. How do we encode the imagery in these formats? And so we have selected the uncompressed codec that is relatively new within MPEG, and then your traditional video codecs, ABC and HEVC. And then the government has done a lot of work over the years with JPEG 2000, especially for geospatial imagery. So J2K and high throughput J2K are really important codecs for us. And these are the mechanisms that we use to encode our imagery. When we move into the metadata space, key length value is a SMPTE standard, and that's been well established in drone systems and those kinds of things. It's an efficient binary encoding. But then when we look at RDF and graph databases, Sparkle, those kinds of things, that's where we're really kind of targeting the ontologically structured information. And then finally, when we look at streaming, we've got MPEG-2 transport stream that's been around for many decades, and now emerging adaptive bitrate technologies like CMAP and DASH and those kinds of things. And so this is kind of our technology stack. And so what we've done is we've built GIMI and the imagery domain ontologies as kind of sitting on top of all this capability. So we get everything in this pyramid, not necessarily for free, but pretty darn close. And so we're doing a significant amount of leveraging here to quickly achieve this broad capability that we're looking for. So the imagery domain ontologies, again, we're really focused on these because they provide an opportunity to do inferencing and reasoning across data sets. So we're really looking at the semantics of the metadata. That's really important for us. And so we've developed a capability within GIMI such that we can tie media contained inside a GIMI file with ontology structured metadata in RDF files or in graph databases. And so right now we're focused on image collection. And so the ontologies that were developed are focused on sensor models, geospatial information. The first ontology that we're delivering is basically a WGS84 coordinates ontology. And we will continue to build on that to create richer and richer ontologies. And so this is a government-wide effort. So we expect that this is going to be a technology that ramps up relatively quickly and starts to see heavy use in the workflows. So with respect to the GIMI-focused requirements and the sprint efforts, we're really focused on the file format. Again, this is relatively new from the GIMI perspective, although ISO-based media file format and HEAF have been around for a long time. We're looking at really accelerating GIMI adoption and application development, and so the work that's being done in the test bed related to the development of open source libraries and some foundational application development becomes really important for us. In addition, the implementation of test tools allows us to confirm that implementations are correct and meeting the requirements of GIMI. With the IDO, again, this is kind of our first run at this, and so it's an opportunity to learn and to adjust where we need to. There are many choices in terms of the design of these ontologies, and so the feedback that we're getting from the test bed has been very important for us. There's a cloud-based GIMI player and viewer that's being developed. And so this is, kind of building on those foundational open source libraries to show functionality. And one of the things that we've spent a lot of time on, where we've had some, I would say, significant successes within the test bed over the last few years, is the cloud optimization aspect of GIMI. These are things that many of them have been foundationally born and developed out of the test beds, and we took some of the ideas from the participants and we submitted those to MPEG, and now those are part of the foundational MPEG standards. And so, that's a big success story from these test beds, and something, again, very important to my customer. And then again, finally, the conformance testing aspect of this is very important to help us kind of ensure that the tools and capabilities that we're developing are kind of on track and everything is headed forward in the same direction. And then finally, the recommendations that we receive from the test bed and the sprints and so forth, those are very valuable to us because they allow us to incorporate those recommendations to kind of help improve the overall capability. So in summary, Testbed 21 is performing foundational work for this effort to get GIMI into adoption across both the government space and in other commercial and industry spaces. And so we view these testbeds is really critical. And the work that's being done, I think, is significant, very important. And we're really looking toward improving the interoperability across the variety of workflows that we have in the geospatial space. And finally, speaking for the GMSB, we are extremely appreciative of all the hard work and successes that are being achieved during these test beds and sprints. The impact is significant. This is going to be a foundational capability, and the work that's being done here, I think, will lead to many additional successes over the next few years. And so thank you, everybody, for your very hard work. It's greatly appreciated, and enjoy the upcoming code sprint. And that's it. I'm happy to take a question or two if there are any.
Thank you, Joe. So maybe we can leave the questions to the end if you can stick around. Okay. I think we'll have some time for that. Okay. And I will give the floor to the next presenter. So I see Shannon, Tom, you are online. Would you like to share your screen, or would you prefer me to run the slides for you?
I can share my screen.
Okay, perfect.
Okay, so I'll be presenting, and then Tim will be presenting after me. So we're here to talk about 3D Tiles 2.0 and glTF 2.1, and the code sprint will be focused on how to like the evolution of these two versions. So for background, 3D Tiles has co-evolved with glTF. So 3D Tiles is a OGC community standard for streaming massive geospatial datasets, and it's been using glTF since the very beginning. So initially with 3D Tiles 1.0, we had the B3DM and I3DM formats, which wrapped binary glTF. And then with 3D Tiles 1.1, 3D Tiles could reference glTF directly as tile content. And glTF and 3D Tiles have many of the same concepts and goals. They're kind of designed almost in parallel. So first is they're designed for efficient transmission of 3D content. So it's meant to be small file size, quickly uploadable to the GPU, and just generally efficient for transmission, and not as much for authoring, more focused on transmission. And then they both have similar concepts, like they both have a scene graph, they both have Cartesian coordinate system, and some of the terminologies or the concepts are similar but different terminology. Like 3D Tiles will have a tile, glTF will have a node. I guess the point is that there's a lot of similarities between these formats, and we're starting to see some trends where 3D Tiles is being adopted outside geospatial. So there's people within the glTF community who are looking for level of detail and for bounding volume hierarchy and other features that 3D Tiles has, and they maybe see 3D Tiles as being very geospatial focused. And we think this is an opportunity maybe to bring concepts of 3D Tiles into glTF. So with that, what we're thinking about this is so glTF 2.0, which is the current version of glTF, is very much at the asset level. So it's like a 3D model that represents the geometry, materials, and textures and metadata. But with glTF 2.1, we're adding the concept of complex scenes, which will include bounding volume hierarchies, level of detail, and external glTF references. And then 3D Tiles will be re-baselined on glTF 2.1, and will have additional extensions that are geospatial focused. So for the sprint goals, we want to bring together the OGC and Chronos communities to advance the integration of 3D Tiles 2.0 with glTF 2.1. We want to identify the gaps in the current glTF 2.1 spec, especially as it pertains to geospatial. And then we want to test compatibility with the existing 3D Tiles and I3S implementations and see what it would take for those to adopt glTF as a new sort of tile streaming format. And then a look at some of the focus areas that we may be considering for the sprint. So we'll be looking at coordinate reference systems, how glTF currently just is a Cartesian coordinate system. It doesn't have CRS support, so we'll look into that. Level of detail, bounding volume hierarchies, structural metadata, streaming scalability, resource bundling, including a possible new binary format for glTF 2.1, and then domain semantics. And with that, I'll hand it over to Tam.
Thanks, Sean. So really why we came to this code sprint is, I think we feel this is like once a decade kind of opportunity to align the 3D graphics ecosystem, traditionally represented by glTF and geospatial, as it has been presented in 3D Tiles and also I3S. So these two systems seem to be merging, and this is a good thing for geospatial as well as other ecosystems, e-commerce, 3D graphics in general. This is a good thing. So early on in the Chronos, where both Sean, myself, I actually serve as the OGC liaison at Chronos, in addition to being an Esri representative. But we've been really advocating how we can bring geospatial experiences into glTF and how we don't lose some of those essence that we actually are fond of and enjoy. And we've been enjoying it for years to sort of build this ecosystem. So we think this is a really great opportunity for members to contribute into that specification process. We don't want it to be done and then kind of come to OGC to get an approval stamp. Rather, members should have the input from the get-go, whether it's on CRS, LOD, or bounding volume hierarchy, as Sean mentioned. There are still areas that are not yet kind of locked down and are still open for discussion and debate and contribution from members. Now, both ecosystems, as you know, 3D tiles and i3s have been evolving over the years and have been serving different needs, but they also both have, attributes and qualities that they bring to the table that would be really cool to preserve as we re-baseline 3D tiles on glTF. And this avoids relearning the same hard lessons that we have done over the years, and also actually bringing this experience to outside of the geospatial ecosystem. And this helps avoid, industry fragmentation that typically we see when we're dealing with, different 3D representation formats being out there. So some of the things, as Sean mentioned in the last slide, that we're really keen and wanting to get feedback from members and from participants of the Code Sprint really revolve around this core essence of geospatial, if you will, coordinate reference systems, attribution or metadata, as well as the different domain types that we're all accustomed to work with when we're working with features. So this is not just geospatial vendors and participants that should be here are actually users of the standards over the years, where we really love to get some feedback as we evolve the glTF format to include this geospatial experience. The other thing that I wanted to bring up is really we are not working in vacuum. Obviously, geospatial is important for all the folks out here. And then Kronos is also going to be there participating in this, which is great. But there are other ecosystems. USD, as represented by AOUSD, which I also participate and work with, is also trying to bring native spatial reference within the USD asset itself. This is something that we're working. Actually, SG is working with the USD community, trying to make sure that native spatial, bringing native spatial awareness to USD is very key. So what are those things that we could learn when we're doing that in USD that could also, cross-pollinate in glTF workflow that we're trying to do? Because the same kind of issues, CRS, metadata, scene composition, are also present in glTF as well as in USD. And they can even go as far as extending this into other ecosystems, such as OpenXR, that also leverage and use 3D content in XR VR environments. So maybe if we can do the next slide, I have, I think, one more slide after this. So really the desired outcomes for us is from the sprint, we want to get, validate glTF 2.0 schema that we've been, working on in the Kronos work group and trying to look at with the members there. We want to validate that here with the OGC members, with the sprint participants around this area, especially CRS, LOD, boundary volume hierarchy, and structure and metadata. I think these are the core issues that geospatial always wants to make sure that they are, retained and also are at the same level of support that they are today in 3D tiles and i3s. And then testing against real-world data set. Joanna mentioned that it would be really cool to get some real-world geodesic assets, and we'll bring some that we can test with, but members are encouraged to bring some of their own test data and data that they are working with, especially problematic ones or those that they think, our complex use cases are really good to test in this workflow. And getting this implementation feedback, before the OGC, before we go on the OGC vote process is very key for implementers and also for a spec editor, I suppose myself and Sean, as we work on these things, it would be really, really helpful. And then, as I said, for the broader community, really the outcome that we would love to see out of this is alignment around this, efforts, OGC, Kronos, and including AOSD, where USD has become even more important, 3D format. How do we actually make sure that there is a continuity and much easier interrupt between these different formats as well going forward. So something to think about in our minds as we work through, bringing this new features from 3D tiles into glTF. And then literally lastly, basically the whole idea of this is lowering the barrier for early adoption. I mean, the idea is that developers, as they get early hands-on experience with the CMS and with the whole concept, when we actually have the format out for adoption, it will not be a surprise or will not be a bigger hurdle to achieve. So I guess with that, we conclude our presentation. Maybe we can have, if there's any questions, we can have a few minutes for that. Joanna.
Great. Thank you so much for the presentation. So before I open the floor for questions, let me just share some information with you about the sprint. Will be just a second.
So, Joanna, whilst you are doing that, let me just share with the participants that with regard to the GeoSciML activity, one of the things that we're really interested in is development of a JSON encoding for GeoSciML. So if anyone participating in the Code Sprint has experience with JSON schema, it would be really great to connect so that we can get some thoughts together regarding development of a JSON encoding for GeoSciML. Thanks.
Okay, thank you, Gobi. So just a bit more information about the Code Sprint. There is a GitHub repository with a folder where you find, for the current year, you will find a folder for this Code Sprint. You can find the presentations, including the presentations that you saw today, in this folder in case you want to download them and check them again. Also, I recommend you to watch the wiki page for the Code Sprint. You can check the QR code there, or there's also the URL, and then you can navigate to the Builder Days Code Sprint. And here you can find the updated information, the detailed agenda, tutorials, and so on. And if you want to share information about the sprint in the social media, you can use the hashtags below. There's also in the GitHub repository, there's an issue to share what you're going to be working during the sprint. If you can share your plans, then other people can know about it and maybe they can join you. Some people already wrote something there, so you can go there anytime before the Code Sprint. And so the virtual component of the Code Sprint will take place on Discord. As I said before, all the meetings will be here in Microsoft Teams in this same meeting that you can find the link in the wiki page. But other than that, we'll have the text channels from Discord where we can continue discussions. So we have the general channel for more general discussions, and then we have topical channels about different standards. If there is, so most standards already have a channel. If there is one that is missing, please let me know and I can add it to the list. Also, all these channels, or most of them, were bridged to Matrix in case anyone prefers to use that. And I think, yeah, so as I said, the video will be on Teams. And I think that's it from my side. So we can open the mic for questions now, whether questions about the Code Sprint, the event itself, or about the presentations that we just saw. So we can use the opportunity that the speakers are here. Okay. Let me check. Yeah, go ahead. Chris?
There's a question for Gobe about the GeoSciML. My understanding GeoSciML is for geology science rather than geo in the wider sense. So Gobe, do you envisage the JSON would be JSON LD orientated, or it'd be or they're not going to go down that LD route?
No, at this stage they won't go down the JSON LD route. So it will be. I mean, it's a research activity, so I'm a bit hesitant to to state exactly what path I think they'll take. But based on the discussions we've had so far, it will. So we're going to develop a JSON schema or a series of JSON schema files for GeoSciML. Now, GeoSciML has some elements that are feature types and therefore having a location element to them, but there are some other types that are not. So I expect effectively, there'll be some aspects that I've effectively modeled on GeoJSON or JSON-FG, but there'll be others that will be, just vanilla JSON schema with possibly nested objects. But it will be interesting. I mean, one of the nice things about the Code Sprint is that you get to discover ideas that you didn't have at the start. So so it will be really interesting to see what's
because I should be there, but the idea I'd like to inject, and I'll mention it now in case anybody has a bright idea, is of course encourage JSON. We're just planning to add in the changes that Kathy Schleight suggested, which was to put in all the, optionally, using JSON LD, to put in all the options to the observations, measurements, and sampling model. So that'll give a whole range of complex feature attributes. So that's just that,
I think that would be interesting. I'd love to discuss that further. And you'll be in London, I presume you'll be in London?
Yeah,
okay,
I'll
that's
be in
great.
London. Right, we'll discuss it
just
then.
to chip in, because I'm here, Chris. So hello everyone, I'm Ed Lewis. I also sit on the CGI committee with Mark Rattenbury.
Hi, Ed.
So there's the different parts of GeoSciML that then is, some are going to be easier and some are harder. So there's GeoSciML, which is a complex features data model, which doesn't easily translate to JSON. It's sort of written around GML. There's a GeoSciML Lite, which is a flattened version, which is meant for like GIS systems. So it's more appropriate for like changing it into a shapefile equivalent or to a GeoJSON. So that should be more easy to do. But yeah, I think for this work, I think we're thinking about how to do the complex features version rather than just the simple one. Is the idea. And but JSON LD is would be a wonderful thing. That would solve part of the problem, but that's got its own pros and cons.
Let's discuss it then, right?
Yeah.
Okay, thank you. So John, I'll just make an observation. So this is regarding 3D tiles and GIMI. I think it would be really good to see maybe a prototype or a demonstration of some kind where we've got a GIMI image, perhaps or a series of GIMI images overlaid in 3D visualization, built using 3D tiles or with 3D tiles on or integrated into that visualization. Basically, trying to identify how GIMI could be integrated into workflows that involve digital twins and are supported by 3D tiles and glTF. It's just a thought. I don't know if it's something that someone might have already explored, but it would be great to see something like that at some point.
Okay, thank you. Are there any more questions? Well,
Yeah, on the GIMI and 3D tiles integration, maybe a good place to start is to add an extension to glTF, because glTF supports a bunch of different image formats. So there could be an extension to support GIMI.
So since you are on the line, I wanted to ask a question also about glTF. So regarding the CRS support, the goal is to have full CRS support, or would you consider at a first stage to have just a default CRS, like in the case of GeoJSON, just default WGS84 or something like that?
Yeah, at least today, so glTF is a like Cartesian coordinate system, and so is 3D tiles. So I think that would be the default, but I think we want to explore like how we put the full suite of CRSs in glTF and 3D tiles.
Okay, thank you.
Yeah, one of the things that we're able to do actually in the this last effort was Gaussian split was exactly that, proposing an extension that extends CRS support so that at least folks that are having, content that is not in WGS84 could work with it. So today, using that extension, it's it's a 3D tiles extension. It's not a glTF, but a 3D tiles extension. You can actually have any coordinate reference system to be part of your 3D tiles, and that works in systems that implement that extension. So the burden is on the systems right now to implement that extension to be able to consume it. So that's where we're at for some of those experiences as well.
I think Chris, you.
Yeah, Sean. Just one idea that you may want to look at is the work that's going on in the GeoZar SWIG. Right, so ZAR itself doesn't know anything about coordinates; it's just arrays with all the stuff about metadata and chunking. But the GeoZar people are trying to add in how they're going to do CRSs on top of Cartesian grids. So they're talking about different conventions to do different types of additional functionality. So it may be worthwhile kind of browsing what they're doing. That's all. Just a suggestion again. Talk about it in London.
Yeah, I'll look into that.
And then while we're on this topic, I just wanted to mention the current work that we're trying to do with USD is exactly around this area, is bringing native spatial awareness into USD. So this might be something that it could really cross-pollinate into those industries, because glTF, USD are much closer to each other than, let's say, the geospatial experience to glTF as it is, at least right now. So that might be something to explore, and I'll be more than happy to bring some of the existing work that we're doing with Trimble, NVIDIA, and others, trying to bring this native, coordinate reference system into USD. The same kind of mechanics and mechanism could be also maybe down the road applied to glTF. But at least for glTF experience, we still have, and we can talk about this at the Code Sprint, but we still have that reference 3D tiles JSON that could carry some of this information around. So, we're not at a disadvantage per se, but it would be really good to see that also down the road.
Okay.
So one question about GIMI, so for Joe. So is there any place where participants can download sample files for GIMI?
I don't think we have any posted on an open public space right now. There have been some files that have been used within the test bed. Yeah, I'm not sure what might be available out there in general, though. Gobi?
Yes, I was just going to say, so in the past month, the testbed has managed to implement support for GIMI and libheaf, and there's still some early work taking place in GStreamer. But basically, with this upcoming testbed, participants will be able to take a GeoTF image, run it through libheaf, and generate a GIMI file. And being able to run different types of images through that, and then pass them on to the conformance testing suite will actually really help inform the testbed, because we'll be able to, to identify any issues if there are with regard to how libheaf or GStreamer handles GIMI. So effectively what I'm trying to say is that with this upcoming code sprint, participants will have at least one or maybe even two open source tools available to them for creating GIMI conformant files.
Okay, thank you, Gobi. And maybe you already generated some of these samples yourself, and you could share them during the code sprint.
Yeah, we've generated quite a number of them within the test bed, so we can share some of them. I don't know if in fact Derek Farren is online, so he's the maintainer of or one of the lead maintainers of libheaf, and I don't know if John Musto is not online, but between John and Derek, they have quite a number of files that they've generated, and I've also done so as well using libheaf. So
I think Derek shared the link for the GitHub
Oh,
repository.
okay.
Thank you.
Oh yeah, excellent.
That's
yeah,
great.
Thank you.
Maybe there's a final question about the presentations or even about the code sprint. Okay. Well, if not, I think we can close the session here. We're just 1 minute before time. So as I mentioned, you can find the presentations in the wiki folder in the repository for the sprint, and I will share the recording later on for anyone who wants to review it. And hope to see you on the 11th, either in person in London or online. Thank you.
Thanks, everyone.
Thanks, John.
Thank
Bye-bye.
you.
Bye.
Thanks all. Bye.